Good evening, students. This is the session 5 from the chapter of circular motion, and this is the Q&A session in which I have taken the question which is written on this board, and this question is based on what we have studied in the previous sessions. So here the question is, a particle is moving with a uniform velocity of 5 meter per second in a uniform circular path of radius 5 meter. So this is the circular path in which a particle is moving in a circular path, and this is the radius of this circular motion is 5 meter. Find the average acceleration when the particle completes half the revolution. So let us consider that this particle is based at this point A. So half the this revolution will be when this particle reaches the other point, that is at B, which is along this diameter. So we know that the circumference of the circle is given by 2 pi r. So it implies that the length of this arc, that is say A, I am just taking this point as C. So the length of this arc ACB, this will be equal to pi r. This the circumference of this circular path is equal to 2 pi r. So the length of this arc, that is ACB, which is half the this circle, this will be equal to pi r. So now here the particle is moving with a uniform velocity of 5 meter per second in a circular path of radius 5 centimeter. So let us say if the particle is at this point A, so since it is moving with a circular with a uniform velocity of 5 meter per second, so the velocity of this particle at this point A will be directed along this arrow. That is, this velocity will be the tangential velocity. Now, when this particle has, let us consider that this particle is moving in the direction as indicated by this arrow. So when this particle reaches this point B, so the direction of the velocity will be pointing in the downward direction. Okay, so the change in velocity will be equal to 5 minus, see, if the velocity is 5 meter per second in this upward direction, therefore the velocity at this point B will be taken as minus 5 meter per second, because we know that this the velocity is a vector. So if this velocity component is taken as positive, then the velocity component when this particle reaches the point B will be taken as negative. So the change in velocity will be equal to it will be equal to 5 minus 5, which is equal to 10 meter per second. Now we have to find the average acceleration. Now average acceleration is equal to change in velocity divided by time interval, or the time taken by this particle to reach from this point A to point B. So we have found the change in the velocity. Now we have to find the time taken by this particle to reach this point B from this point A. So let us say the time taken, say it is t, this will be equal to the length of this arc, that is ACB, which is equal to pi r, and pi r is 5 meter divided by the velocity of this particle. So this is equal to pi seconds. So this is the time taken by this particle to reach from this point A to the point B, or it is a time taken by this particle to complete half the revolution. So it implies that the average acceleration it will be equal to the change in the velocity, that is 10 meter per second, divided by that time taken to complete this half half the revolution, which is equal to pi seconds. So the average acceleration will be equal to 10 upon pi meter per second square. So the average acceleration of this particle when it completes half the revolution will be equal to 10 upon pi meter per second square. So thank you very much for joining this session, and in the next session I will be coming up with a different type of a question, but it will be based on what we have studied in the previous sessions. So thank you very much. Have a nice day.